Hi, I am Anindam Mulli and you all are welcome to my channel Technical Ori. Live with Programming. Our today's topic is tree data structure. We are discussing about the what is tree. What do you mean by the tree data structures? Let's start. First of all, what is tree? A tree is a non-linear hierarchical data structures consist the nodes which is connected by the edges. Again I repeat, a tree is a non-linear hierarchical data structure which are consist the nodes connected by the edges. Why? What is the meaning of non-linear hierarchical? I will explain after some time. And there is a note. Tree is a recursive data structure. Why is a tree is said is a recursive data structure? I'll explain after some time. Okay, when we are our discussion is progressed, I will explain why it is called recursive data structure. So simple way, just you can understand it that tree is a non-linear hierarchical data structure. That's why, as you know, you are habituated with the linked list and array. There is another data structure for storing the data in a orderly. Okay, so tree also is the same. Is a tree is a data structure storing the data. Okay, so now this is an example. Okay, this diagram. This is a diagram of tree. First of all, why it is called non-linear? Tree is a non-linear data structure. Why? Why it is non-linear? Means why it is non-linear? Why it is not a linear? If you clearly observe this is a call. First of all, this is called nodes. This one, this two, this is a nodes. Okay, means tree is a collection of nodes. We can say also say that tree is a collection of nodes, or nodes is the elements of a tree, and nodes are connected to each other by using this straight line. It's called edges. Okay, this is the edge. This is the edge. Okay. So tree consists the nodes and nodes are connected to the by using edges. Okay. Now, why it is called non-linear? First of all, if you have clearly observed this structure, this is a tree. Okay. This arrangement is a not a like a orderly. First of all, why? That for an example, like there is a one. Okay. Then there is a two. Okay. Fine. There is a another is a three. So then there is a no elements. Okay. Same way, there is a 2, there is a 4, 5, no element. Not orderly, like, they are not maintaining any order. Is there any maintenance order here? Yes, it is a data structure, no doubt. It's a data structure. We are storing the data, right? But here is a we are not maintaining like the order as a array. Same way, for an example, like, what is the array? In case of array, like, first of all, this is zeroth index. Then index number 1, index number 2, one by one. Is one after another, one after another. But here is not a just one after another. Like there is a 1, okay, fine, there is a 2. Okay, there is a 4 here. Okay, there is a 3 here. Okay, means not in a just one after another. Or after that, this 3, 5 is here. Okay, next 5, this 6 is here. There is a no element. Okay, so there is a like a such type of arrangement not maintain like the order like a array or the linked list. Same way as if you are considering about the linked list also. One node, okay, then link with another node, link with another node, link with another node, okay, one after another, one after another. Here not one after another. Here 3, after that is no node. Or now if you are coming on that this node, this is 2, 4, 5, okay, there is a no node. So like as a order, it is also just not maintain the order like a array or linked list. So here maintain the another type of arrangement. It is a special type of arrangement. It is known as tree data structure. Now another thing is a hierarchical. Same way, just think about that your family members. First of all, your grandfather, grandmother. From your grandfather, grandmother, then the next generation coming your father. From your father and mother, in the third generation, you are coming. So there is a hierarchy are maintained. Same way, if you are considered there is a leveling, so this is a first level, second level, third level, so fourth level. So on the first level, 1 is there. Second level, 2 and 3 is there. Third level, 4 and 5 are there. Fourth level, 6, 7, 8 are there. So it's a level by level. Maintain a hierarchy. So tree is the hierarchical data structure. Now, having some nodes, obviously the nodes connected with the edges. Yes, these straight lines, these called edges. So these nodes are connected to each other using the edges. So it is a tree. But why tree is a recursive data structure? I will explain after some time as our discussion are go forward. Okay. Now there is some terminology. First of all, what is node? Nodes are basically the elements of a tree. Okay. As I already explained, this 1, 2, 3. These are the nodes. Okay. So tree consists some nodes. Next, what is edges? Edges are the like a branches of a tree. These edges is a like a these are think about just it is a like a branch. This tree have some branch. This is a branch. This is called edges. Okay. By using edges, nodes are connected. Nodes are connected to that one node to another using edges. So we are saying edges are like a branches of a tree. Next is root node. Root node is the topmost node of any tree but has not any parent. This in this diagram, what is that root node? 1. Root node means the topmost node. So obviously in this diagram it is clear that 1 is the topmost node. Another note, another thing is that the definition of the root node. Root node have not any parent. Yes, 1 have not any parent. Next is child node. What is child node? Like this is a 1 we can say it is a parent node. Parent node for an example. What is a child node? Child of 1. Like there is a left part, there is a one child, that is 2. This is called child node. 2 and 3 is a child node. We can say this is a child node of which? What is a parent node of the 2 and 3? 1. So 1 is the parent node, child node is the 2 and 3. Same way, 4 and 5 is the child node of which parent? What is the parent of 4 and 5? 2. How can I say that it is a parent node, it is a child node? Just think about that. From which node this child are coming? From 1, the 2 or 3 are coming. Just clearly observe this way, okay? Like for an example, like from 2, 4 or 5 are coming, 4 and 5. Same way, 6, 7, 8 are coming from this 5. From 5, these 6, 7, 8 are coming. This is a child node. Leaf node. Leaf node is a node which have not any child. For an example, this 6, 7, 8, 3, 4 is a leaf node. Why? As our definition says that leaf node has not any child. So obviously we just clearly observe that 4, 6, 7, 8. Is there any child node? No. No child node. So obviously these 4, 6, 7, 8 and 3 is at the leaf nodes. But not any child. Is a leaf node. Subtree. Subtree is the descendant of a node. Subtree means this is a subtree. This is a one subtree. This is another subtree. Though it is a just one node, obviously it is a tree. It is a tree. Yes, it is possible. There is only one node, but still it is a tree. Have not any child. So this is a subtree. This is another one subtree. This is another subtree. This is a left subtree. Why it is called left subtree? I will explain after some time. Just keep in mind this is a subtree. Like a descendant or child. Child part. Okay. This is a left child. This is a left subtree. This is a right subtree. Path. Path means a sequence of consecutive edges is called path. A sequence of consecutive edges. Consecutive means one after another, one after another. Okay, consecutive sequence. Maintain a sequence which consecutive edges. So we can say that the definition of the path, that is a sequence of consecutive edges, are called path. This sequence of consecutive edges like 1, then 2, then 4. These are one sequence. So 1 to 2, 2 to 4. Then 1 from 1, then 2, then 5, then 7. So 1 to 2, 2 to 5, 5 to 7. Another path that is means consecutive. This is a consecutive 1, then 2, 2, then 5, then again consecutive 8. Consecutive. Right? So sequence of consecutive edges is called path. 1 to 2, 2 to 5, 5 to 6, another path possible. So lots of paths are possible, right? Again I repeat, 1 to 2 like 2 to 4, 1 to 2, 2 to 5, 5 to 7, another path, 1 to 2, 2 to 5, 5 to 8, another path, 1 to 2, 2 to 5, 5 to 6, another path, 1 to 3, another path. These are lots of paths, but we take the consecutive edges, sequence of consecutive edges. Degree. What is the meaning of the degree? Degree means in a node that how many child node have. Means a parent node have how many child is called the degree of that node. Another thing is the now what is the degree? Now for an example, like what is the degree of what is the degree of 1? 1 have the how many child? 2 child. 1 is 2, another is 3. So degree of 1 is 2. Now what is the degree of this 2? How many child are there? 4 and 5. 2 child. Now what is the degree of 5? 1, 2, 3. 3 child are there. So obviously it is a degree is 3. Okay. That means a node have the how many child node. If a node have the how many child nodes, it is called the degree of that node, that particular node. That means how many child of this 5? 1, 2, 3. So what is the degree of 5? 3. How many child of the 2? 1, 2. So what is the degree of this 2 node? 2. What is the degree of 1? How many child? 2, 3. So degree is 2. Height. Height means longest path. I already explained what is a path. On that path, which is the longest, means maximum number of edges are covered. It is called the height of the tree. Okay. For an example, like how can I calculate height? I'll explain after some time. Okay. This is like a small example. I'll discuss small example. I think it is a clear your concept on the tree. This is just a small example. Let's take a tree. So now this A is a topmost element and have not any parent node. So obviously A is a root. A is a root. Now this straight line is called the edges. And this A, B, C, D, E, F, G is the nodes. Nodes of this tree. Okay. Now this part of the left part of the root is called, this is a left subtree. This is a tree obviously. This small things, it is also a tree. This is another tree. It is called subtrees. Okay. But it is as this part, this B, D, E, this part is a left part of the A root node. And C, F, G is the right part of the root node. So it is called right subtree. And B, D, E is the left part of the root. So the left subtree. Now leaf node, which is called leaf node, a node have not any child. So D, E, F, G have not any child. So obviously is a leaf nodes. Now what is the degree of A? As I already told that how can I calculate the degree of a node? How many childs are there? How many childs of A? B and C. 2 child. Degree is 2. How many childs of B? 1. D and E. 2 child. Degree of B is 2. Now path. Like Consecutive edges, sequence of consecutive edges. One means A B E, A B E, A B D, A B D, A C F, A C F. Okay, same way. It's a path. Now height means the longest path. Longest path. How can you calculate? What is the longest path? First of all, A to B, B to D. That means 1, 2. Path is path. That means how many edges? 2. Means height means the longest path. Means maximum number of edges are covered. That is the height of a tree. Now we check the another path. A to B, B to E. 1, 2. How many edges? 2. Again you calculate. Another path. A to C, C to F. How many edges? 2. Again you calculate. A to C, C to G. How many edges? 2. So if you calculate the all paths, we get the just maximum the 2 edges. So what is the maximum edges we find? 2. So height is 2. So height of this tree is 2. Simple way. 1, 2. This is a 1, 2. Or 1, 2. Same way. Just we are calculate every time we find the 2. So height is 2. Binary tree. What is binary tree? A binary tree is a hierarchical data structure in which each node has at most 2 children. Binary tree is a hierarchical data structure, right? But each node must have at most or maximum 2 children. Yes, minimum it is 0 children or 1 children. Okay, it is allowed. But maximum each node has 2 children, up to 2 children. It is means it is a minimum 0 children or 1 children. Okay, it is a binary tree also. I'll explain after some time with some example of the binary tree. But for now, just understand the definition. A binary tree is a hierarchical data structure in which each node of the binary tree has at most or maximum, each node has the maximum 2 children. It's called binary tree. This is example. Or we can say that tree having the degree 2. That means maximum 2 children. Now, I have a question. Is a binary tree? Just one node are there. Yes, it is a binary tree. Why? What is the definition says that? Maximum. Each node has a maximum 2 children. Minimum 0 children also possible. 1 children also possible. Yes, it is a binary tree. It is a binary tree. Yes, only 1 children are there. Okay, no problem. It's a binary tree. It is a binary tree. Yes, maximum how many children? 2. Yes, 2 children are there. Binary tree. Is it the binary tree? No. How many children are there? 3 children. Maximum how many children a binary tree have? 2. But here it is 3. Not possible. It is not a binary tree. Next, complete binary tree or strict binary tree. Complete binary tree is a special type of binary tree. Have the either 0 child, that means no children, or otherwise have the exactly 2 children. Means have 0 children or exactly 2 children. 0 or 2. 0 children or 2 children. This is called complete or strict binary tree. Complete binary tree or strict binary tree. Again I say that the definition again, a binary tree which have the either 0 child or exactly 2 child is called complete binary tree. This is an example. Okay, this is a complete binary tree. Yes, definition says that 0 child. Yes, it is a 0 child. It is a complete binary tree. Now, is a complete binary tree? Exactly 2 child. Yes, this node have the exactly 2 child. Yes, it's a complete binary tree. It is a complete binary tree? No. How many child this node has? 1 child. Not possible. Complete binary tree, each node have the either 0 child or exactly 2 child. But here is this node have the 1 child. No, it is not a complete binary tree. Okay. This is another way. This is a way. Okay. This is a complete binary tree? This is a complete binary tree. Now, if you are just clearly observe that, how many childs are there? How many childs are there? This, if you calculate this, yes, it is this is the thing, like 1 2 child, okay, fine. But here how many childs are there? How many childs are there? 1. This is another way. There is a lots of definition, lots of way to say it is a complete binary tree. Okay. So here, but yes, up to this it is a complete binary tree, no doubt. Up to this is a complete binary tree. No, but this is a way. This is like a way, simple just definition of the complete binary tree. But now I have also told you the another way. That thing, I think it is a clear your idea more. This is a, if we are represent a tree using the array, we are take a array, though we know that in C and C++ index are starting from 0, but for good understanding we are starting our index from 1. Now how can we create this array? Just do the some level by level traversal. First level element, then second level, third level. So first level y, okay, index number 1. Then second level bc, then d e f g, d e, then f g. So that's why we created this array. Okay. Okay. Now how can I find if we have there is a tree and you try to find that it is a complete binary tree or not? This is a simple way. How? The rule says that if the starting index, that is 1, and ending index, that is 7, between these two, a and g, that means 1 and 7, 1 to 7, if there is a no gap, is a complete binary tree. Is there any gap from like index number 1 and between index number 1 and 7? No, all elements are present. After the 7 there is a maybe gap. Yes, it is a complete binary tree, no doubt. But between the starting index element and ending index element, is there any gap on this array? No. Rule says that if there is a no gap between the starting index element and ending index element, it is a complete binary tree. So yes, it is a complete binary tree. But here, if you are observed, it is not a complete binary tree. How? Why it is not a complete binary tree? If I represent this tree as an array, first is A, then BC, okay, BC, then no elements, so we are taking the two gaps, then EF, okay. So now we are checking, is there any gap between the A and F, or in the first index element and last index element? Yes, there is a two gap. It is not a complete binary tree. Full binary tree is a in which every node other than the leaf nodes having the exactly two child. It's called full binary tree. Again I repeat, full binary tree is a tree in which the every nodes other than the leaf nodes have the exactly two children. It's called a full binary tree. We have the another definition. What? Having the maximum number of nodes in the height of the tree. No space are present for inserting the another nodes. If we try to insert the another nodes, height are changes. This is called full binary tree. And keep in mind, this is not. If you proved the tree, a tree is a full binary tree, then you say yes, it is also complete binary tree. That means every full binary tree is a complete binary tree. It is a node, short node. Every full binary tree is a complete binary tree. Now, this is a full binary tree? Yes. Why? Every node other than this leaf node all have the exactly two children. Yes, this node have the exactly two children. This node have the exactly two children. This node have the exactly two children. Yes, it is a full binary tree. Same way, this node other than this leaf node, other nodes have the exactly two children. Yes, it is a full binary tree. Now, there is another rule for finding the is a full binary tree or not. Rule says that if a tree is a full binary tree if the tree have 2 to the power h plus 1 minus 1 number of nodes on their heights, where h represent the height of the tree. For an example, what is the height of this tree? How can I calculate the height? Longest path or maximum edges. Calculate the edges. Okay, fine. First of all, 1, then 2. This A to B, 1, B to D, 2. Then A to C, 1, C to G, 2, 1, 2. 1, 2. So 2. So height is 2. So height of this tree is 2. Now, rule says that a full binary tree have the 2 to the power h plus 1 minus 1 number of nodes. So h value is 2. So 2 to the power 2 plus 1, 2 to the power 3 minus 1, that means 7. So 7 means 7 nodes are present. Calculate, is there 7 nodes or not? Check, we check that. 1, 2, 3, 4, 5, 6, 7. Yes, 7 nodes are present. Obviously, this is the full binary tree. This is another definition of the full binary. So a full binary tree have 2 to the power h plus 1 minus 1 number of nodes, where h represent the height of the tree. Now, if you ask me a question, sir, if we try to insert the another nodes, what the problem arise? We check. For an example, if you insert the another node, obviously is the left part of the D or left hand side of the D, left child. What is the height now? If there is a node 1, 2, 3, so heights are changes, right? Now I have a question. There is a tree. Is a complete binary tree? Sorry. Yes, it is a complete binary tree. Why? Why? If I represent this as an array, just array representation. Think about the array representation. Because there is some problem arise on the representation of the complete binary tree, but I suggest you that use the array representation. Then you find if there is a gap, complete binary tree. If there is a gap, not a complete binary tree. If there is a no gap between the first element and last element, complete binary tree. If you have checked level by level, first level, second level, third level, okay, fourth level. Yes, after the last there is a no node, okay, no problem, because the level by level are fulfilled up. Okay, this is a complete binary tree. Up to the height, that means there is a property of a complete binary tree. A complete binary tree is a full binary tree up to height h minus 1. Keep in mind, this is a short note. A complete binary tree is a full binary tree. A complete binary tree is a full binary tree up to height h minus 1. That means what is the height value? If we are go to the before the height, means decrease the height by 1 up to that height, that this complete binary tree is a full binary tree. How? We will explain. On this example, okay, what is the height of the tree? 1, 2, 3. 1, 2, 3. Longest path or maximum edges. 1, 2, 3. How many edges? 3. Longest path. 1, 2. So longest is 1, 2, 3. But that means height is 3. I think you are now habituated with how to calculate the height of a tree. I think it is clear up to you. Now, how to try to our property says that a complete binary tree, no doubt is a complete binary tree. I already explained why it is a complete binary tree. All levels are fill up. Yes, it is a not fill up, is a last. No matter. If there is a empty space on the last, no problem. After the last index element, this is empty. No problem. It is a complete binary tree. Yes, it is not a full binary tree, but up to height this. That means if there is a height is 2, up to height 2, it is a full binary tree. Because every node other than this node have the 2 child, exactly 2 child, is a complete binary tree. So, I think it is clear up to you the basic parts of the tree, data structure. On the next video, I will explain about the tree traversal techniques. Thanks for watching my video.